Let f from r minus 0 to r be a function such that f of x minus 6 times f of 1 upon x, which is equal to 35 upon 3x minus 5 by 2. So to find f of x, let us replace x as 1 upon x, so that the equation 1 becomes f of 1 upon x minus 6 times f of x, which is equal to 35 by 3x minus 5 by 2. Let's eliminate f of 1 upon x. So multiply this equation with 6. So we'll get 6 times f of 1 upon x minus 36 times f of x is equal to 6 times 35x upon 3 minus 6 times 5 upon 2. So we can write it as minus 36 times f of x plus 6 times f of 1 upon x is equal to 70 times x minus 15. So let us consider this equation to be 2. Now adding 1 and 2, so we'll get f of x and here minus 36 f of x and minus 6 times f of 1 upon x plus 6 times f of 1 upon x gets cancelled, and the other side 35 upon 3x plus 70 times x minus 5 by 2 minus 5 by 2 minus 15. So we can write minus 35 times f of x is equal to 35 upon 3x plus 70 times x, and here it is minus 35 divided by 2. So we can take out 35 common. So we can add 1 upon 3x plus 2x minus 1 by 2. So we can cancel this 35 on both the sides, and hence we can also write f of x is equal to 1 by 2 minus 1 upon 3x minus 2x. Now we have f of x is equal to 1 upon 2 minus 1 upon 3x minus 2x. Now let's consider the limit. X tends to 0, 1 upon alpha x plus f of x, which is given as beta, where alpha and beta are the real numbers. So we can write limit x tends to 0, 1 upon alpha x, and f of x we can write 1 by 2 minus 1 by 3x minus 2x, which is equal to a finite value real number. And here, as x tends to 0, 1 upon alpha x minus 1 upon 3x plus 1 upon 2 minus 2x. Since the limit value is finite value, and here 1 upon alpha x and 1 upon 3x is defined, 1 upon alpha x minus 1 upon 3x is defined only when alpha is equal to 3. So that 1 upon 3x minus 1 upon 3x will become 0. So alpha must be equal to 3 to get the limit value. And so that limit x tends to 0, we have 1 upon 2 minus 2x is equal to beta. Applying the limit, so we get 1 upon 2 is equal to beta. So alpha is equal to 3, beta is equal to 1 upon 2. Therefore, alpha plus 2 times beta is equal to 3 plus 2 times 1 upon 2, which is 3 plus 1, which is equal to 4. So 4 is the answer, which is option 4. We need to find the limit x tends to 0. Cosecant x we can write 1 upon sin x. Under root of 2 cos square x plus 3 cos x minus root of cos square x plus sin x plus 4. So to avoid confusion, let us consider cos x is equal to some c and sin x is equal to s, and cosecant x is equal to 1 upon sin x. So we can write 1 upon s. So that the given expression we can write it as limit x tends to 0, 1 upon sin under root of 2 cos square plus 3 cos minus under root of cos square plus sin plus 4. Let us do rationalization. Multiply and divide with limit x tends to 0 under root of 2 sin 2 cos square plus 3 cos minus under root of cos square plus sin plus 4 into under root of 2 cos square plus 3 cos plus under root of cos square plus sin plus 4 divided by under root of 2 cos square plus 3 cos plus under root of cos square sin plus 4 into sin, so that the numerator can be written as applying a plus b to a minus b. So we get 2 cos square plus 3 cos under root whole square minus under root of cos square plus sin plus 4 the whole square divided by s times, that is sin x under root of 2 cos square x plus 3 cos x plus under root of cos square x plus sin x plus 4. So which is equal to limit x tends to 0, 2 cos square x plus 3 cos x minus cos square x minus sin x minus 4 divided by sin x of under root of 2 cos square x plus 3 cos x plus under root of cos square x plus sin x plus 4. We can write this as limit x tends to 0, 2 cos square x minus cos square x, that is cos square x, and plus 3 cos x minus sin x minus 4 divided by sin x of under root of 2 cos square x plus 3 cos x plus root of cos square x plus sin x plus 4. So let us split into two. Limit x tends to 0, cos square x plus 3 cos x minus sin minus 4 divided by sin into limit x tends to 0, 1 upon under root of, let me write cos square as c as cos x, so 2 cos square x plus 3 cos x and again plus under root of cos square x plus sin x plus 4, which is equal to, and here let us simplify, 1 upon under root of 2 into, since cos 0 is 1, so 2 into 1 square plus 3 into 1 plus under root of, that is 1 square plus 1 plus 0, sin 0 is 0 plus 4. So which is equal to 1 upon, here 2 plus 3 5, root 5 plus root 5, that is 2 root 5. So limit x tends to 0, or here I can write before that 1 upon 2 root 5 into limit extends to 0, cos square x plus 3 cos x minus sin x minus 4 divided by sin x. Now here in this limit, when we substitute x is equal to 0, so we'll be getting cos 0 is 1 plus 3 minus 0 minus 4 divided by 0. So which is 0 by 0 form. Let's apply L'Hospital rule so that we can differentiate numerator and denominator separately. So we'll get 1 upon 2 root 5, limit extends to 0, differentiation of cos square x is 2 cos x into differentiation of cos is minus sin x plus 3 times differentiation of cos is minus sin x and minus differentiation of sin x is cos x and differentiation of constant is 0 and divided with the differentiation of sin x is cos x. So 1 upon 2 root 5, limit extends to 0, 2 cos x sin x is sin 2x, we can write sin 2x minus sin 2x minus 3 sin x, and here it is cos x divided by cos x. Now it is not 0 by 0 form. Let's apply the limit extends to 0. So we'll get 1 upon 2 root 5 into minus 0 minus 3 into 0 and again minus 1 divided by cos 0 is 1. So which is 1 upon 2 root 5 into negative 1. So minus 1 by 2 root 5 will be the answer. So which is our option 2, minus 1 by 2 root 5. For some n is not equals to 10, let the coefficients of 5th term, 6th and 7th terms in the binomial expansion of 1 plus x whole to the power of n plus 4 be in arithmetic progression. Then we need to find the largest coefficient in the expansion of 1 plus x whole power n plus 4. We know that in the expansion of 1 plus x whole power n, tr plus 1 is equal to ncr x to the power of r. So here 5th coefficient, 5th term means we can write t5 is equal to t4 plus 1, that is n plus 4 c 4 x to the power of 4, and t6 we can write it as t5 plus 1, which is equal to n plus 4 c5 x to the power 5, and t7 we can write t6 plus 1 is equal to n plus 4 c6 x to the power of 6. Since the binomial coefficients, the coefficients are in arithmetic progression, so we can consider these terms n plus 4 c4, n plus 4 c5 and n plus 4 c6. These are the binomial coefficients. They are in arithmetic progression. So we can write here n plus 4 c4 comma n plus 4 c5 comma n plus 4 c6 are in arithmetic progression. And we know that if a comma b comma c are in arithmetic progression, then we have 2 times b is equal to a plus c. So here we can write 2 times n plus 4 c5 is equal to n plus 4 c4 plus n plus 4 c6. So let us simplify 2 times, and we know that NCR formula is n factorial divided by n minus r factorial into r factorial. So we can write n plus 4 factorial divided by n plus 4 minus 5, that is n minus 1 factorial into 5 factorial, which is equal to n plus 4 factorial divided by n plus 4 minus 4, that is n factorial into 4 factorial plus n plus 4 factorial divided by n plus 4 minus 6, that is n minus 2 factorial into 6 factorial. So here n plus 4 factorial in the numerator can be cancelled, and here we can write 2 upon n minus 1 factorial into 5 factorial is equal to 1 upon n factorial. We can write it as n into n minus 1 into n minus 2 factorial into 4 factorial plus 1 upon n minus 2 factorial into 6 factorial. We can write 6 into 5 into 4 factorial. Similarly, in the left side, we can write n minus 1 into, so we can write here n minus 1 into n minus 2 factorial, and 5 factorial we can write 5 into 4 factorial, so that the denominator 4 factorial gets cancelled and n minus 2 factorial gets cancelled. Now let's simplify. 2 upon 5 times of n minus 1 minus 1 upon n into n minus 1 is equal to 1 upon 30. Taking LCM, 5 into n minus 1. So here 2 times n minus here 5, which is equal to 1 upon 30. So here 5 6 times we can cancel, and cross multiplication 12n minus 30 is equal to n square minus n, or we can write n square minus n minus 12n plus 30 is equal to 0. That is n square minus 13n plus 30 is equal to 0. We can write n square minus 10n minus 3n plus 30 is equal to 0. So n taken common, n minus 10 minus 3 times n minus 10 is equal to 0. So n minus 10 into n minus 3 equals to 0. So n is equal to 3 or n is equal to 10. But it is given that n cannot be equal to 10. So n is not equals to 10. So we consider n is equal to 3. So let's consider n is equal to 3. So that we have the expansion 1 plus x whole to the power of 3 plus 4, which is 1 plus x whole to the power of 7. And clearly we can say that the middle term will be the greatest coefficient. Largest coefficient in the expansion of 1 plus x whole power n. So we can consider to be, so number of terms will be 8. So 8 by 2, that is 4th term. So we can write t 3 plus 1, that is 1 plus x whole to the power of, so t3 plus 1 is equal to 7c3 x to the power of 3, that is 7 factorial. We need to consider only the coefficient. The largest coefficient can be taken as 7c3, or we can take 7c4 also. So 7 factorial divided by 3 factorial into 7 minus 3 4 factorial, that is 7 into 6 into 5 into 4 factorial divided by 3 into 2 into 1 into 4 factorial. So we can write 7 5s are 35. So 35 is the greatest binomial coefficient, which is option 2. Let the product of focal distances of the point root 3 comma 1 by 2 on the ellipse, the standard form of ellipse, x square upon a square plus y square upon b square is equal to 1, where a is greater than b, is given 7 by 4. Then the absolute difference of the eccentricities of two such ellipses. So we know that if theta is the parametric coordinate, a cos theta and b sin theta, then the product of focal distance at the point theta is given by sp into s dash p is equal to a square minus a square e square cos square theta. So let us use this formula here. Here root 3 comma 1 by 2 is the point. Let us consider to be a cos theta and b sin theta. So that product of the focal distances SP into S dash P is equal to A square minus E square into A square cos square theta. That is A cos theta whole square. A cos theta we can write it as root 3. So here A square minus E square into root 3 whole square. So we got A square minus 3E square and the product is given by 7 by 4, which is equal to 7 by 4. So we can write A square is equal to 7 by 4 plus 3 times of E square. Let us make this an equation 1. And now B square is equal to A square times of 1 minus E square. This is a relation we have. Make this as an equation 2. And also, since root 3 comma 1 by 2 passing through is a point on the ellipse, so we can write root 3 comma 1 by 2 is a point on ellipse. So we can write root 3 whole square divided by A square plus Y square, that is 1 by 2 whole square divided by B square is equal to 1, which implies 3 divided by A square plus 1 upon 4 times of B square is equal to 1. Make this an equation 3. Now let's substitute from the second equation B square is equal to A square of 1 minus E square in the third equation. So we get 3 upon A square plus 1 upon 4 times of A square into 1 minus E square is equal to 1. So we can take out 1 upon A square common. So 3 plus 1 upon 4 times of 1 minus E square is equal to 1, or we can write it as 3 plus 1 upon 4 times of 1 minus E square is equal to A square. And also from the first equation, A square value 7 upon 4 plus 3 by 3 E square. So here we can write 3 plus 1 upon 4 times of 1 minus E square is equal to 7 upon 4 plus 3 times E square. For our convenience, let us consider, let E square is equal to P. So that we can write 3 plus 1 upon 4 times of 1 minus P square is equal to 7 by 4 plus 3P. Sorry, here P. Simplifying, we can write 3 minus 7 by 4 is equal to 3P minus 1 upon 4 times of 1 minus P. So here we can write 5 by 4 is equal to 3 4s are 12P times of 1 minus P minus 1 divided by 4 times of 1 minus P. So cross multiplication, 4 gets cancelled here. So 5 times 1 minus P is equal to 12P minus 12P square minus 1. 5 minus 5P is equal to 12P minus 12P square minus 1, or we can write 12P square and here minus 5 minus 12 minus 17P and here 5 plus 1 6 is equal to 0. So that P is equal to 17 plus or minus under root of 289 minus 4AC. So 4 6 are 24, 24 into 12. So divided by 2 into 12. So 24 12 times we can write it as 288. So 17 plus or minus 289 minus 288 is 1. So divided by 24. So we can write 18 by 24, and another value we can write 17 minus 1, that is 16 by 24. So here 6 3 times, 6 4 times. So we can write P is equal to 3 by 4, or we can write here 4 4 times, 4 6 times, or again 2 by 3. So here we can write or 2 by 3. So which implies your P is nothing but E square. E square is equal to 3 by 4 or 2 by 3. Hence we can write E is equal to square root of 3 by 4 or square root of 2 by 3. So let us consider E1 is equal to root 3 divided by root 4 is 2, and E2 is equal to root 2 divided by root 3. And we need absolute difference of E1 eccentricities, E1 and E2. So clearly we can say root 3 by 2 is greater than root 2 by root 3. So we can take root 3 by 2 minus root 2 divided by root 3. So root 3 into root 3 is 3. 3 minus 2 root 2 divided by 2 root 3 will give the absolute difference between the eccentricities. So we can go with an option. Option 4 is the answer. 3 minus 2 root 2 divided by 2 root 3. First, let us find the image of the circle. X square plus y square minus 2x plus 4y minus 4 is equal to 0. With respect to the line, 2x minus 3y plus 5 is equal to 0. So to find the center of the circle, we know that if the circle equation is given x square plus y square plus 2gx plus 2fy plus c is equal to 0, then the center can be taken as minus g comma minus f, and the radius r is equal to under root of g square plus f square minus c. So here in this circle, center I can write, let us mark it as a center P. So 1 comma, so here we can write it as minus 2, and radius under root of g square, that is minus 1 whole square, and f square, that is 2 square, minus of minus 4, which is equal to under root of 1 plus 4 plus 4, which is equal to 3. So we got the radius 3 units, and the center is 1 comma minus 2. So we need to find the image of this point. Image of this point with respect to the line. With respect to the line ax plus by plus c is equal to 0. Let us consider the images here. P dash, say h comma k. So we have the relation h minus x1 upon a is equal to k minus y1 upon b is equal to minus 2 times of ax1 plus by1 plus c upon a square plus b square. So let us apply the concept here. We need to find the image of the point 1 comma minus 2, say x1 y1, and say here the O center, let us take it as h comma k. So we can write h minus 1 upon 2 is equal to coefficient of x is 2, and k minus of minus 1, that is k plus 2 divided by coefficient of y is minus 3 is equal to minus 2 times of ax1, that is 2 into 1 2 into 1 2, minus 3 into minus 2 that is plus 6, and again plus 5 divided by 2 square plus 3 square minus 3 whole square. That is h minus 1 upon 2 is equal to k plus 2 divided by minus 3 is equal to minus 2 into 13 divided by 9 plus 4 13. So minus 2. So we can write h minus 1 upon 2 is equal to minus 2. So we can write h minus 1 is equal to minus 4. So h is equal to minus 4 plus 1, that is negative 3. And similarly, k plus 2 upon negative 3 is equal to minus 2, which implies k plus 2 is equal to 6. So k is equal to 6 minus 2, which is 4. So therefore the center of the circle, required circle C is h 4 minus 3 comma 4. Say this is O minus 3 comma 4. Obviously the radius will be the same as the first circle because it is image of the circle. So radius is equal to 3 units. So we got the center of circle C is both minus 3 comma 4 and its radius is 3 units. Now let's see the second part. A be the point on the C such that OA is parallel to x-axis and A lies on the right hand side of the center of the O. So let us mark the point is here. And if point B alpha comma beta, B is alpha comma beta, where beta is smaller than 4, which means it lies should be below the 4. Here 4 units are there. So B should be below the OA such that the length of the arc AB is equal to length of arc AB is equal to 1/6 of the perimeter of C, that is circumference, perimeter of the circle C. So we can write perimeter of the circle is 2 pi r, 2 into pi into, and radius r is equal to 3 units. So we can write 3. So 2 into 3, 6 get cancelled. So length of arc is pi. So this length AB is equal to 6 units. And also we know that the length of the arc when theta is an angle, theta by 360 degrees into 2 pi r, and the length is given as pi. So here r is 3 units. So here 2 3s are 6, 60 times, and pi get cancelled. So here we can write angle theta is equal to 60 degrees in degrees. When angle is 60 degrees and it's below, so let us consider the angle is negative 60 degrees when we are taking, and the parametric coordinates of the point B, we can write h plus r cos theta comma k plus r sin theta. So let us consider theta is in negative direction because it is in anti-clockwise direction. So it is clockwise. So minus 60. So we take the point B, h plus, that is minus 3 plus r is nothing but 3 units into cos of minus 60 degrees, and k plus, that is 4 plus r, that is 3 times of sine of minus 60 degrees, which is equal to minus 3 plus 3 times of cos of negative theta is equal to cos theta, and cos 60 value is 1 by 2. So here we can write 1 by 2 comma 4, and sine of negative theta is equal to minus sine theta, and sine 60 is equal to root 3 by 2. So here we can add minus 3 into root 3 by 2. So minus 6 plus 3, minus 3 by 2. And here it is 4 minus 3 root 3 divided by 2. So this is alpha and this is beta. Now we need to find beta minus root 3 times of alpha. That is 4 minus 3 root 3 by 2 minus root 3 times of alpha value is again minus 3 by 2. That is 4 minus 3 root 3 by 2 plus 3 root 3 by 2. So which on simplifying we'll get the answer 4. So we can go with an option B. 4 is the answer. Given alpha and beta are the roots of the equation 2z square minus 3z minus 2i, where I is equal to under root of minus 1. That is I square is equal to negative 1. So we can write it as 2z square minus 2i is equal to 3z, or dividing with z on both the sides. Or dividing with 2z. Let us take 2z. So that we can write 1 upon, sorry. So here z minus I by z, which is equal to 3 by 2. Let's squaring on both the sides. So we get z square plus I by z whole square minus 2 times of z into I by z, which is equal to 3 by 2 whole square is 9 by 4. So that is z square, and I square value is minus 1, so minus 1 by z square minus 2i is equal to 9 by 4. Again squaring on both the sides. So we get z square minus 1 by z square minus 2i whole square is equal to 9 by 4 whole square. So we can add z square whole square, that is z power 4, plus 1 by z square whole square, that is 1 upon z power 4, and plus 2i whole square, and here minus 2 into z square into 1 upon z square, and again here plus 2 into 1 upon z square into 2i, and again here minus 2 into z square into minus 2i, which is equal to 81 by 16. So we can add z power 4 plus 1 by z power 4, and I square is minus 1, so 4 minus 4 and minus 2, and here we can write 4i by z square, and again minus 4iz square is equal to 81 by 16. Now we can rewrite z power 4 plus 1 upon z power 4 minus 6 plus, and if it is taken minus 4i common, so we can write z square minus 1 upon z square, which is equal to 81 by 16. So from here, so here we can write z square minus 1 upon z square is equal to 2i plus 9 by 4. So z power 4 plus 1 by z power 4 minus 6 minus 4i into 2i plus 9 by 4, which is equal to 81 by 16. So on simplifying, we'll get z power 4 plus 1 by z power 4 minus 6 minus 4 2s are 8, I square is minus 1, so plus 8 and again minus 9i is equal to 81 by 16. Let's simplify, so we can get z power 4 plus 1 upon z power 4 is equal to, so 8 minus 6 is 2, so minus 2, so 81 by 16 minus 2 plus 9i, which implies z power 4 plus 1 upon z power 4 is equal to 16 to the 32, 81 minus 32 is 49, so 49 upon 16 plus 9i. Since alpha and beta are the roots, alpha is a root, so we can write alpha power 4 plus 1 upon alpha power 4 is equal to 49 by 16 plus 9i. Similarly, beta is also a root, so we can write beta power 4 plus 1 upon beta power 4 is equal to 49 by 16 plus 9i. Now consider alpha power 19 plus beta power 19 plus alpha power 11 plus beta power 11 divided by alpha power 15 plus beta power 15. So let us take common alpha power 15. So we'll get alpha power 4 plus 1 upon alpha power 4 and again beta power 15 taken common. So alpha power 4 plus beta power 15 taken common. So beta power 4 plus 1 upon beta power 4 divided by alpha power 15 plus beta power 15. And we know that alpha power 15, alpha power 4 plus beta power, alpha power 4 plus 1 upon alpha power 4, beta power 4 plus 1 upon beta power 4, both are same. So I can take out and I can simplify alpha power 4, or let us consider to be something p. So we can write p into alpha power 15 plus p into beta the power 15 divided by alpha power 15 plus beta power 15. So p taken common. So alpha power 15 plus beta power 15 divided by alpha power 15 plus beta power 15. So the value is p. P is nothing but 49 by 16 plus 9i. So that now the real part of this alpha power 19 plus beta power 19 plus alpha power 11 plus beta power 11 divided by alpha power 15 plus beta power 15. So let us consider to be something x, so that the real part of x is equal to 49 by 16 and imaginary part of x is equal to 9. So according to the question, we need 16 times real part of x into imaginary part of x, which is equal to 16 into 49 by 16 into imaginary part is 9. So 49 9 times, so 36 plus 8, 441. So 441 is the answer, which is our option C. Given a statistical data with 10 observations, x1, x2 and so on up to x10, and a student obtained the mean as 5.5 and summation of xi square is 371, and he later found that he noted two values in the data are incorrectly as 4 and 5 instead of the correct values 6 and 8. Then we need to find the variance of the corrected data. So here we can say the old sum, that is summation of xi, since the mean is equal to old mean, and here it is the mean is 5.5 and summation of xi divided by 10. So the sum can be taken as 5.5 into 10, which is equal to 55. So the old sum is 55 and hence new corrected sum can be taken as from 55 we have to remove the wrong entries and we have to add the correct entries. So we can write 55 minus wrong entries are here 4 and 5. So 4 plus 5 wrong entries sum we can write plus and the correct entries are 6 and 8. So 55 minus 9 plus 14. So here we can say 60. Therefore, corrected mean is equal to corrected sum divided by the total number, that is 60 upon the values will not change, so 10 values are there, so 60 upon 10 is 6. So this is the correct mean. Say this is summation of or we can say the x dash bar. And let us see the squares. Given that summation of xi square is equal to 371, so this is the old one. So the new corrected sum of the squares is which is equal to 371 minus we have to subtract the square of the wrong entries, that is 4 square plus 5 square, and we need to add the square and new entries 6 square plus 8 square. So we can write 371 minus and here it is 25 plus 16 41 and again here 8 square plus 6 square is 100. 471 minus 41 we can get 430. So the new correct sum of squares is equal to 430 and we have the formula for variance. Sigma square is equal to summation of xi square divided by n minus summation xi by n whole square, that is mean square. So here the variance of the corrected data can be taken as summation of xi square, the new one is 430 divided by the number of observations are 10 minus and summation xi by n is nothing but the mean. So corrected mean is nothing but 6. So we can write 6 square which is equal to 43 minus 36 which is equal to 7. So 7 is the answer, which is our option A. Given the sum Sn is equal to 1 upon 2, so we can write 1 into 2 plus 1 upon 6, we can write 2 into 3 plus 1 upon 12, we can write 3 into 4 plus 1 upon 20, so we can write 4 into 5 and so on up to n terms. Up to n terms means we can write 1 upon n into n plus 1. So we know the concept. 1 upon n into n plus 1, we can write it as 1 by n minus 1 upon n plus 1. So here 1 upon 1 into 2, we can write it as 1 minus half, and here 1 upon 2 into 3 we can write 1 by 2 minus 1 by 3, and 1 upon 3 into 4 we can write 1 by 3 minus 1 by 4, and so on, 1 upon n minus 1 upon n plus 1, so that we can cancel half, 1 by 3, 1 by 4, and so on. 1 by n will be cancelled with the before term. So there are only two terms remaining. We can write Sn is equal to 1 minus 1 upon n plus 1. That is n plus 1 minus 1 divided by n plus 1, that is n upon n plus 1. And it is given sum of first 6 terms of an AP. Sum of first 6 terms of an AP, whose first term is given minus p and common difference is p. We can write it as 6 by 2, 2 into minus p, because we know the formula, sum to n terms in AP is Sn is equal to n by 2, 2a plus n minus 1 into d. So here a is equal to negative p and common difference d is equal to p. So plus n minus 1, that is n is equal to 6. So we can add 6 minus 5, 5 into p, which is equal to 3 times of 5p minus 2p is 3p, which is equal to 9p. And the sum is given 2026 times S 2025. So here S 2025 we can write it as, so this is Sn, so 2025 divided by 2026. So 2026 get cancelled, and square root of 2025 is, so 45 square is 2025, so 45 we can give. So 9p value, that is S6 value, is given as root of 2026 into S 2024. So 9p is equal to 45. So 9p is equal to 45. So which implies p is equal to 5. Then the question is about the absolute difference between 20th term and the 15th terms. That is T20 minus T15, which is equal to a plus, so here a is equal to negative 5, that is minus 5, and common difference d is equal to plus 5. So a plus 19d minus a plus 14d. So here we can add a plus 19d minus a minus 14d, which is equal to 5 times d, that is 5 into d, 5 value. So 5 5 is a 25. So 25 is the answer, which is our option 4. Given the function f of x is equal to 2 to the power of x plus 2 plus 16 upon 2 power 2x plus 1 plus 2 power x plus 4 plus 32. Let us simplify this. F of x is equal to, we can add 2 power x into 2 square plus 16 divided by, here 2 power 2x into 2 into 2 power 1 plus 2 power x into 2 power 4 plus 32. So 2 square taken common, that is 4. So 2 power x plus 4 divided by, and here it is taken 2 common. So we can write 2 power 2x, we can write 2 power x whole square. And here we can write 2 into 2 power x into, so 2 power 3 will be there. So we can write 2 square. Plus again 32, 2 is taken common, so 16 will be there. So we can write 4 square we can write. So which is equal to 4 times 2 power x plus 4 divided by 2 times of 2 power x plus 4 whole square. So 2 power x, 2 times of 2 power x plus 4, here the denominator will get cancelled. So we can write, so 2 upon 2 power x plus 4. So this is the function f of x. Now let us consider f of x plus f of 4 minus x, which is equal to 2 upon 2 power x plus 4 plus f of 4 minus x we can write 2 upon 2 to the power of 4 minus x plus 4. Thus simplifying, 2 upon 2 power x plus 4 plus 2 upon, and here 2 power 4 is 16, 16 divided by 2 power x we can write plus 4. And simplifying, let us simplify here. So 2 into 2 power x divided by 16 plus 4 times of 2 power x. So if 4 is taken common, so 2 into 2 power x divided by, we can add 4 plus 2 power x. So that 2 power x divided by 2 times of 2 power x plus 4. So let us add both. So we can get 2 divided by 2 power x plus 4 plus 2 power x divided by 2 times of 2 power x plus 4. So taking LCM, 2 times of 2 power x plus 4. So here 2 times, that is 4 plus 2 power x. So that the numerator and denominator 4 plus 2 power x, 2 power x plus 4 get cancelled. So the answer is 1 by 2. So we can conclude that f of x plus f of 4 minus x is equal to 1 by 2. Now here let us consider f of 1 by 15, and 4 minus 1 upon 15 is 60 minus 1, that is 59 upon 15 is equal to 1 by 2. Similarly, f of 2, 2 by 15 plus f of 58 by 15 is equal to 1 upon 2. So here the question is 8 times f of 1 by 15 plus f of 2 by 15 and so on, the middle number f of 30 by 15, because there are total 59 terms are there. So in which there are 29 pairs of the numbers, 1 upon 15 plus 59 upon 15, 2 upon 15 plus 58 upon 15 and so on. 29 pairs are there. So that you will get 8 times of 29 times, each pair the sum is 1 by 2. So 1 by 2 plus, and one more is middle number, that is f of 30 by 15. So this f of 30 by 15, that is f of 2. F of 2 we can write, since f of x is equal to 2 divided by 2 power x plus 4. So 2 divided by 2 power 2 plus 4, that is 2 upon 4 plus 4, 8, which is equal to 1 upon 4. So we can write here 1 upon 4 is the value. So 8 times 29 by 2 plus 1 by 4, which is equal to 8 times, here the denominator 4 is LCM, 4, and 29 2 times 58 plus 1, which is equal to 2 times 59. So 59 2 times 118. So we can go with an answer 118. which is option A. Given that the three lines 3x minus 4y minus alpha is equal to 0, 8x minus 11y minus 33 is equal to 0, and 2x minus 3y plus lambda is equal to 0 are concurrent. So let us use the condition here. So we can write 3 minus 4 minus alpha, 8 negative 11 and negative 33, and 2 minus 3 and lambda. The determinant is equal to 0. So here we can write 3 times the determinant of minus 11 minus 33 minus 3 and lambda, and again, so this is plus minus and plus, so negative of negative will become plus here, so plus 4 times of leaving this column and the row, so we'll get 8, so we can write here 8 minus 33, 2 and lambda, and again plus minus alpha times of, so leaving this column and the row, so we get 8 minus 11, 2 and negative 3, which is equal to 0. So we can write 3 times minus 11 lambda and minus 99 plus 4 times 8 lambda minus 66 minus or minus plus 66, and again minus alpha times of minus 24 plus 22 is equal to 0. So here we can also write it as minus 33 lambda, and here it is 297, and again plus 32 times lambda, and here 240 plus 24, 264 plus 24 alpha, and again minus 22 alpha is equal to 0. So we can simplify 24 alpha minus 2 alpha, 22 alpha is 2 alpha, and minus 33 and plus 32 is minus lambda, and minus 297 plus 264 will get 33, negative 33 is equal to 0. So or else we can write it as 2 alpha minus lambda is equal to 33. Make this an equation 1. Now let's consider about the image of the point 1 comma 2 with respect to the line 2x minus 3y plus lambda is equal to 0, and it is given by 57 upon 30 comma minus 40 upon 13. So let us use the formula image of point with respect to the line. So we can write 57 upon 13 minus 1 divided by the coefficient of x is 2, which is equal to k minus y1, that is minus 40 by 13 minus 2 divided by the coefficient of y is negative 3, which is equal to minus 2 times of ax1, that is 2 into 1 minus 3 into 2, 6 plus lambda divided by a square plus minus 3 whole square is 9. So 57 minus 13, that is 44 divided by 2 into 13, which is equal to minus 40 minus 26, that is minus 66 divided by negative 3 into 13, which is equal to minus 2 times of 2 minus 6 is minus 4. So lambda minus 4 divided by 13. We can see that in the denominator 13, we can remove that, and we can also even cancel with 2 times, 2 1 times, 2 33 times, and again 2 22 times, and here 2 11 times. So we can write 11 is equal to, and here also 3 11 times, so 11 is equal to minus of lambda minus 4. So we can equate 1 lambda minus 4 is equal to negative 11. So lambda is equal to 4 minus 11, that is negative 7. So let us substitute lambda is equal to negative 7. So in the equation, we got it previously from 1, that is 2 alpha minus lambda is equal to 33. So which implies 2 alpha minus of minus 7 is equal to 33. So 2 alpha is equal to 33 minus 7, which is equal to alpha is equal to 33 minus 7. So which is 26. 26 upon 2 is 13. So the value of alpha is 13 and lambda value is negative 7. And we need to find mod of alpha lambda, which is equal to alpha is 13 and here negative 7, which is equal to negative 91. Since mod is there, so we'll take only 91. So 91, which is our option 1. Let's simplify the equation. X square minus 9x plus 11 whole square minus of x minus 4 into x minus 5, we can write x square, negative 4x, negative 5x, that is negative 9x, and here plus 20 is equal to 3. Or let us consider x square minus 9x plus 11. Let us take it as a variable t. So we can write t square negative minus of, so here we can write t plus 9 is equal to 3. We can write t square minus t negative 9 negative 3 is equal to 0. That is t square minus t minus 12 is equal to 0. Simplifying, we get t square minus 4t plus 3t minus 12 is equal to 0. So we can factorize t minus 4 into t plus 3. So we are getting t is equal to 4 and t is equal to negative 3. So when t is equal to 4, that is x square minus 9x plus 11 is equal to 4. That is x square minus 9x plus 7 is equal to 0. 11 minus 4 is 7. And here we can say the discriminant delta is equal to, that is b square minus 4ac for a quadratic equation ax square plus bx plus c equals to 0. So here we can write negative 9 whole square minus 4 into 1 into 7, that is 81 minus 28, which is equal to 53, not a perfect square. Since it is not a perfect square, we can conclude that this equation having and delta is greater than 0, so we can say they are real roots. So they are irrational. We can consider they are not rational, having irrational roots. Now let's consider t is equal to negative 3. When t is equal to negative 3, so we can write x square minus 9x plus 11 is equal to negative 3. That is x square minus 9x plus 14 is equal to 0. So here we can find the discriminant delta is equal to b square minus 4ac, that is negative 9 whole square minus 4 into 1 into 14, that is 81 minus 14 fours are, we can write 56. 81 minus 56, 25, which is a perfect square. Hence we can say this equation is having rational roots. Let's find the rational roots here. So here we can at x square minus 7x minus 2x plus 14 is equal to 0. So x minus 7 into x minus 2 is equal to 0. So the roots, rational roots are x is equal to 2 and 7. Therefore, product of all rational roots, here only two rational roots are there. Product is equal to 2 into 7, which is equal to 14. So which is our option A. Given that a set S is equal to P1, P2 and so on P10 with a set of first 10 prime numbers. So we can take S is equal to 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. So these are the 10 prime numbers. And A is equal to, set A is equal to S union P. S union P, where P is a set of all products of the distinct elements of S. So here we can write, suppose if I consider 2, comma 3, comma 5 and so on 29, all the 10 prime numbers we can choose, and along with that we can choose the product of distinct elements. Let me consider 2 into 3. So I can write 2 into 5, or I can write 2 into 3 into 5. Like the different possibilities we can write. So this is A set. And now the number of all ordered pairs x comma y, we need to find the number of all ordered pairs x comma y such that x belongs to the set S and y belongs to the set A, such that x divides y. So it is mentioned that x divides y. So that is y upon x is equal to some value. Say that lambda is lambda. So y is equal to some x into lambda. So we can choose the ordered pairs like, suppose if I take 2 as x, so we can take any number of multiples like 2 comma 2 I can choose, or 2 comma 2 into 3 I can choose, or 2 comma 2 into 3 into 5 I can choose, and so on. Similarly, I can take 3, 3 comma 3 I can choose, 3 comma 3 into 5 I can choose, any number of multiples like 3 into 3 into 5 into 7 and so on. Similarly, to like 29, I can choose 29 comma 29, or 29 comma 29 into 2 comma 29 comma 29 into 2 into 3 and so on. So we can mention, so the number of possible ordered pairs. So we can say first 2, 3, 5 and so on 29, there are 10 numbers are there. So we have 10 numbers, and for each number we can choose either other remaining, means other remaining numbers are, if I choose 2 is the number, then the remaining are 9 numbers are there out of 10. So 9 numbers are there. So either from the 9 numbers I can choose 0 numbers, so that I can take only 2 comma 2. So 9C0, or either I can choose one more 9C1, that is 2 comma 3, 2 into 3, sorry, 2 comma 2 into 3 and 2 into 3 into 5. I can choose 2 numbers, or I may choose 3 numbers, or I may choose up to 9 numbers in the product. So these are the possibilities for each number. So totally 10 are there. So 10 times of 9C0 plus 9C1 plus and so on 9C9 which is equal to 10 into, we know sum of the binomial quotients is 2 to the power n, so 2 to the power 9, that is 10 into 512. So we can say the answer is 5120. So 5120 will be the answer. It's a numerical question. So we need to find the number of 3-digit numbers which are divisible by 2 and 3 but not divisible by 4 and 9. So we have 3-digit numbers are the number of 3-digit numbers which are equal to 900, because from 100 to 999, so 999 minus 100 plus 1. So 900 numbers are the 3-digit numbers, and which divisible by 2 and 3, divisible by 2 and 3, so we can take it as 900 divided by 6, plus 2 into 3 6, which is equal to 150. So the numbers which are divisible by 2 and 3 can be taken as 150. And now the numbers which are divisible by 4 and 5, 4 and 9, so we can write 900 divided by 4 nines are 36, so which is equal to, so here 25 4, 9 4 times and 900 times, and 100 by 4 is 25. So 25 numbers which are divisible by 4 and 9. So we can conclude that three-digit numbers which are divisible by 2 and 3 but not divisible by 4 and 9 is given as, so from 150 minus 25, that is 125. So 125 numbers are there, 3-digit numbers which are divisible by 2 and 3 but not divisible by 4 and 9. So 125 is the answer.